one thing we'll see in radar and wind up. MIMO radar virtual array. So we are creating a radar array. So you see here, the radar is going to work at 77 gigahertz. I am going to have a 2-element transmit array and 4-element receive array. So transmitting is only 2 elements, receiving is 4 elements. So I'm going to work at 77G, and see here NT is 2, NR is 4. So I'm just running section by section so that we will have. So I am creating the transmitter array and receiver array, and I am creating that. I'll just run section by section and we'll see if there are any errors, some issue with the code. This is the pattern of the arrays: transmitter, receiver, and two-way pattern. You can see how the signal is at 0 degrees. You see maximum power is transmitted. Away from 0, you can see the power is reducing drastically. So if everything is lambda by 2 spacing, you call them as full array. Now you see I am I'm changing the spacing. You can see how the pattern is changing. Able to visualize. So I am just changing the distance between the antennas so that I am seeing what is the effect on that. So you can see the variation in direction pattern. This is the two-way pattern. So I am having transmitting array with 2 lambda spacing, receiver array with 0.5 lambda spacing. I am having a virtual array of 0.5 lambda spacing. So for that, if you run, you can see what is the variation in the direction pattern. My goal is whatever pattern I send, the transmitting and receiving pattern should be same. The last thing it gives me the full array pattern and the virtual array. Virtual array is what I simulate, and two-way pattern is what I actually get. And virtual array is that you assume that transmitting array is only 2 elements and receiving array is 4 elements. You adjust the spacing so that you have a virtual array of 0.5 lambda. Okay, the spacing is the key thing. So even though you have uneven number of elements, the spacing, if you do it carefully, you can attain the direction pattern as you require. Now I am going to simulate a TDM radar. And just running each section so that finally we'll see the output. I'm processing the elements. I'm decoding the answer, and finally I'll be plotting the response. Finally, you see plot response. So plot the response of the radar. At these points, you can see there was an object detected at 50 meters and 50 meters detected 2 objects with different speed. One is stationary and one is moving at 45 meters per second. Okay. You want to squeeze the map. If you want to see in dB scale, you can do that. We just estimated the target. You have to run the code and finally you have to plot. And this is the spatial spectrum of what angle, what is the power which is transmitted by the radar. You can see at 0 degrees, you have the physical array, you have the maximum power 0 dB. 0 dB is 1 watt. Okay. So even radar processing has become very simple using MATLAB. It has become very simple using MATLAB. So this is some of the examples I just wanted to share.